Good morning, good afternoon, good evening, whenever and wherever you are, my friends. My name's Alex, and I'm here to show you beat 'em ups, turtle style. In this particular video, we're only going to be covering the absolute basics to get the camera set up and get that early game feel in. In part 2, we'll be building a finite state machine to really refine the animations and the movement. Okay, so I have a general blank screen here. I haven't done anything to this build yet except for change the canvas size. And you can do that with me now or create a brand new project. We're going to go into our properties and we're going to make sure that we set this to 1920 by 1080, which is full resolution. And then we want to disable this update resolution during the game to fit the screen window. We're going to go ahead and hit apply. The only other thing that I need to do before we get started is to show the grid. And now we're going to go add some objects. So we're going to start by making a player collider, the collision for the game, and then we're going to be making a player platforming sprite. So we're going to be using all things baked into Gdevelop to be able to make this. And we're going to be using two of the pre-built tools to make it work. And I'll explain how it works as we build it. So the first thing that we want is our game feel, and to do that, we need to zoom in our canvas a little bit. Because we're using pixel art, it's a good idea to start at a bigger resolution that's the same aspect ratio at whatever canvas you've chosen, and then zoom into it. So in this particular case, I'm going to be zooming into 480 by 270, which is from 1920 by 1080, a ×4 zoom. And so to better visualize that, and to make sure our camera gets to the right place, we're going to create a generic sprite, and we're going to call this canvas. We're going to create it with Piskel, and I'm going to name it canvas again. Then we're going to use the fill bucket and choose a random color. I'm going to choose like a light blue just to make it really obvious, or a teal, I guess. Someone tell me what color that is. And we'll hit, we'll set that in, and then we'll hit apply. We can now add that into our game, and we're just going to stretch this up to 480, make sure we unlink it, and then we'll set it to 270. So now we have our level canvas in place. So let's make sure we get that right by going to our event sheet, opening up the events, and we're going to trigger a beginning of the game scene event. So at the beginning of the game scene, we're going to target the canvas with a camera. And we're just going to type action camera, and then we're going to center the camera on an object, and we're going to center it on the canvas. We don't need to set anything here. That's fine. And the next thing we want to do is zoom in. Now we're going to go to our actions. We're going to type zoom, and we're going to camera zoom 4 times. Hit apply. I'm actually going to rearrange this so we zoom before we center on the camera. I'm going to hit preview, and now you can see it takes up the entirety of the screen. Excellent. So the next thing for us to do is build our collisions and then add our player collider, which is going to be using the top-down game mechanics that are built into Gdevelop, so up, down, left, right, and diagonal. And that's how we're going to get that smooth movement inside of the game. So I want you to imagine that the canvas is now the road in a game like Teenage Mutant Ninja Turtles or Streets of Fury or 1,000 other games that are beat 'em ups. But this is now the ground. This is the area that we're going to be walking on. We're going to cover a little bit of it up here in a minute, but we now need something to block us, like the walls in the background that stop us from moving, or the walls on the edges so that we don't fall out of the map. So to do that, we're going to create a new sprite object. We're going to call this collision, and we're going to create it with Piskel. This one can be the default 32 by 32. We're going to call it collision, and per usual, I'm going to use a big bright red color for this. We're going to hit apply. Now what I want to do is surround our project here, our little canvas area, with a little bit of these borders. Gonna duplicate this. So now we have this area all the way wrapped in. Now, for the most part, a brawler would probably have a less walking room than the entire canvas because the walls kind of seep down into our game. If I preview now, we can see here we have that walk room. But what is a really big feature in this is not only being able to move within this area, but also having the camera follow us just a little bit. So to get that effect, we need to start this with a new sprite, and we're going to call this object underscore player collision. Now this object is going to manage all of those top-down properties. So quickly we'll give it a generic color and shape, and let's see here, we need to rescale this down. And so I want to do a width of 64 by a height of 16. So we're going to resize this. Now we got this long little strip, and I'm going to go down and choose a purple color. Now you can choose whatever color you want. It's irrelevant, but I want something a little bit darker. There we go. And now we're going to add the behaviors for this object. So we're going to go over to the behavior tab, add a new behavior. We want to make this character the top-down movement character. Now, out of the box, the movement settings are a little bit too fast for us, so we're going to change them up. Now, I've already played around with these settings to make sure I got it right. So let's just copy my settings here. We're going to keep default controls on, and we're going to set our deceleration to 400, our max speed to 150, and we're going to leave allow diagonals on. But what we're going to turn off is the rotate object. If we don't do that, our character will rotate in a 360 degree arc around in circles to try to follow the movement directions that we're pressing. We don't want that. We want this to act like a top-down character. So now if I add that into our game, and to make this at scale a little bit, we're going to change the grid to 16 by 16. Zoom in here a little bit, hit preview, and now we can see our player object is able to move through this area. Now, their collisions don't work currently. So that's the next step that we wanted to do, as well as having the camera follow a little bit behind it. So we're going to jump back over to the untitled scene. We're now going to create a new event, and the condition here is to check for collision. So we're going to click on the collision. We're going to type collision, and we're going to select the object player collision. So it should read something like the collision is in collision with the object player collision. A lot of collisions, but that's all right. We're then going to use an action called separate. So separate kind of works like collision, like actually blocking it, but we're able to keep one object in position and stop another object from pushing into it. So what we want to do is separate, and we're going to choose the player object, and we select the collision as what doesn't separate. So now this will allow our collision to walk right up to that red spot, and it'll stop immediately. Now you could preview it now if you wanted to make sure that that works, but I'm going to take this one step further and add in that camera movement before we go check this out. So the next condition that we need to check is the Y position of our player collider. And to do that, we can click on the player collider, scroll down here until we find the position. We're going to be looking for the Y position. You could also just type it. And we're going to be checking if it is less than 200 pixels. That means if you're within the top 200 pixels of the screen, we're then going to start triggering this action. And now what we need to do is actually move the camera. Now, for some of you, this might be a little bit outside of your comfort zone, but I'll explain to you what math we're doing, or basically how it works, and we'll go from there. So we're going to be selecting the camera center Y position. This is going to allow us to move our camera only up and down and not left and right. So when we go into this, we need to use a function called lerp, which allows us, it's a linear interpolation, which means it takes one point, your starting point, and then it takes the end point, the position of something else that you want, and then we move the object that we have selected, which is our first one, to that position at a percentage, and that is represented by a decimal. So to not talk your ear off and to show you how this actually works, we're going to go into lerp, and we're going to start with the camera because that's what we're going to be targeting. Again, we're targeting the center Y position. Now this does come with, it does accept input. You could leave it blank, but it's really important that we fill this out, especially if we're going to have different layers that move around in our game. So we want to make sure that what we're passing into this call is the layer itself. So we're going to be calling base layer, and it's a lowercase in the second part. And then we're going to be targeting the default 0 camera. After this, we're going to do a comma, and then we need to target our object player collider, and we need to target the Y position on that collider. Now, because of the size of the player sprite that I'm going to be using, I'm going to be pushing the camera to follow a little bit higher above our player, which means we need to minus a value, because in Gdevelop, negative Y is up on the screen. And then we're going to do 48. And then we need to do another comma. And now we need to pass through the percentage that we're sliding it. And we're going to do 0.9, which effectively means we're like moving at like 10%. Or like it's keeping up. I guess we're moving at a delay of 10%. So this should allow a very smooth camera, and I'll show you what that looks like now. We'll preview. And now as we move up, we can see that our camera moves, and as we move down, it takes us back to as far as it'll go, which is at the very end, that 200 mark. So we can see a little bit up here, but that's left us with a little bit of a gap, and so we'll just go back to our game scene, that adjustment real fast. And now we have the basics of our movement system. As you saw, we can move up and down and diagonally inside of here. But the next step is to add our player character. Now for this, you're going to need your own sprite. Now you can make your own and follow along with a blank sprite at the same size as what I'm using, or to bring whatever sprite you want into this so you could practice alongside. Otherwise, you can just use a blank sprite. But I'm going to be using, specifically for this tutorial, my main man, Donatello. So we're going to go into our sprite. I'm going to call this SPR for sprite, and then we're going to name it player. I'm going to import an image, and we're going to go into our game here, and we're going to import our first image. We're going to loop this and press preview, and we can see Donnie's kind of cruising there. He's going a little bit faster. We're going to change this to about 8 frames a second. A nice fluid movement. And I'm going to name this idle. We're going to add another animation, and I'm going to change this to jump. I'm going to import a picture here, and I'm going to upload my jump sprites. And then one more, and this will be walk. Add sprite. So we're going to add Donnie to the project. Now, Donatello's sprite, as you can see, is massive. There's so much room around him. It's 256 by 256. So if you were to create this character as it is, it would generally, it's actually just 64 by 64. So if you're going to do a blank canvas model, just do 64 by 64, and you can follow along from there. So because Donnie is so big, we actually have to go into the player sprite and adjust the points. Now, if I check the collision mask, we can actually see that Gdevelop has customly cut out the character, which actually works out really well. So that's good for us. And then we're just going to go to the point, and we want to make sure that the origin point is down between the feet of your character, and then the center is near the center of your character. We're going to hit close and apply, and that'll move our character. We just got to recenter it. So right now, this sprite doesn't actually do anything. Well, we need to bind those two things together and give it animation, as well as add some behaviors to the player sprite, which is actually going to be the 2D platforming element of our character. And that's going to give us the ability to jump and use some of those pre-built Gdevelop tools to our advantage. So if we create something that is a platforming character, we must also have objects that are labeled as as a platform. And to do that, we're actually going to go to our player collider first, and then we're going to add the behavior, and we're going to add the platform behavior. We're just going to turn off ledges can be grabbed and hit apply. So now once we go back to our player sprite and go into its behavior tree and add the platforming character behavior, the character will now collide with that piece. So ideally, we want to make some adjustments here for at least my player sprite. Yours might be a little bit different, but the concept here is going to be the same. What I want you to do is lower down your jump speed, because the overall height of your jump in this one is kind of more based on the resolution size. You got to make sure you're not like jumping beyond the current camera size. We're going to turn the jump sustainability down to 0.15. We're going to turn off the automatic grab, and we're going to set our acceleration and our deacceleration to 0. We're going to turn off can jump through platforms when you to go down, and we're going to set max speed to 0. And the reason why we're doing this currently is because with the default controls enabled in our player behavior, when we press the arrow keys, it'll try to move the character. But we're actually going to be binding this to the object, the player collider object, and basically they use the same, because they're both using the default keys. They'll conflict and move each other at the same time. But we want to use positioning to do that for the player object and not the default controls. So later on, we'll be turning off default controls anyways, because we're going to be in part 2 developing a finite state machine to really finitely control our player down, to add a lot more of that complex beat 'em up behavior. So that's all we needed there. Enough said. Hit apply. And we're going to go back into our untitled scene. We just have a few more lines of code to add, and then we're done for the basic movement. We need to now check the player to make sure that we are moving the camera in the right way and moving the player in position at the right location. So what that ends up looking like is a player check on the player sprite, and we're going to be checking if the player is and isn't jumping. So we're going to copy and paste that, click on it and press J, or you can double click it and invert the condition. So now we have isn't jumping and is jumping. So if we are jumping, or rather if we aren't jumping, we're going to move the player sprite on top of the player collider to give it that overlap and make sure that they're kind of like bound together like one object. So to do that, all we have to do is target the player sprite, or in this case, the player sprite, and we're going to check both of its X and Y location. You can do this by going back down to position or typing position and an X and Y, but because we're doing both, we might as well set it to position. So the X position here is going to be the object player collision X position, and then we're going to add 28 pixels because of how big Donnie is. I have to move him over a little bit. You might not need to. You might need to do this by 32, because if you're doing 64 by 64 on your model, 32 would be the middle point. But because of where I put my point, it's arguably not in the center, so 28 is where I found the sweet spot. And then we're going to change the Y position to object underscore player collision Y. We're going to take the top of that object and just put the player right on top of it. So that's perfect for that. We're going to hit OK. And now what we want to do is basically check then if the player is jumping, and then what happens there. Well, we don't need the Y to be tracked anymore when the player's jumping, because we're still tracking the player's base, and now we're going to be tracking, and we want to continue to track that when the player jumps. So the best way for us to manage that is to add the action for the player sprite, and we're going to type POS for position, and then we're going to be just checking the X position on this one. And it's going to be exactly the same value as the other one. So that's the object, player collider, and then this is X, and minus for you 32 probably if you're using a 64 by 64 model, or for me 28. roughly 28. I might need to adjust that a little bit more, but we'll see. And we're actually, it's not a minus, it is a plus. Make sure that you don't do that wrong. I almost did that wrong. And now we can go check our preview. We can jump, and we can see that our player, if we use the arrow keys left and right, up to follow our player around, and jump works. Look at that. It's pretty amazing. So now we need to just add a little bit more because I added some animations and I want that final little bit of polish. We are going to be rebuilding this in part 2 to include the finite state machine, which is going to allow a lot more restricted control over our players to get the true beat 'em up experience, to allow for all the nuances of those engines that we need to, like the grappling and all these trigger events that we're going to have to do later on. So that will be rebuilt, but I wanted to show you the basics of how to get all of that. So if you're just here for the basics, you're done. You can head out. The rest of this video is for the rest of you. So if you're heading out, please, would you kindly give me a like, a comment, subscribe. All right, back to the video. So the next thing that we want to do, I'm going to move the sprite is and isn't jumping into this event group. Okay, so I'm just going to name this group player manager for now. And I'm going to tuck these into the manager. Now, make sure that jumping isn't jumping is on top. That's really important because Gdevelop reads top down. And we actually need to stuff two actions in between these two. And the reason is because as it reads top down, isn't jumping can then be overwritten by is jumping. And if is jumping is on top, anything below it will overwrite it. So jumping needs to be on the bottom. That won't matter when we build a finite state machine, but just in case you wanted to get some early jump onto seeing how you could manage this movement style really basically, we're going to do that from here. So we're going to add in a new event. I'm going to duplicate it because we only need 2 more. And we're going to be checking whether or not the player collider is moving and whether or not it is not moving. So actually, I guess I could have just had you do that. And we're going to check is moving first and then is not moving after. All we have to do now is set up the animations. So if the player isn't jumping, that doesn't matter. If the object is moving, well, I imagine you can understand that our player object then should animate to a move. So we're going to go to animate by name and set it to walk. We're going to copy that and paste it into isn't moving, and we're going to change that into idle. And lastly, copy paste to the very bottom is jumping, change that to jump. So now you can see we have our walking animations, our jumping animation, and these walls that lock us in. So there you have it. This is the basics of the beat 'em up brawler camera engine. And from this point, the next thing we do is our finite state machine and whatever else you guys want to see. So if you like this video, give it a thumbs up, give it a comment, and let me know what other beat 'em up mechanics do you want to learn about so that you can make the best beat 'em up out there using Gdevelop. Well, until next time, remember, happy game making, and I'll see you in the next video.